First land plants. It was hard to find evidence of the first land plants because fossils require hard parts on organisms, and plants mainly only have soft tissues. It took 500 to 600 million years for plants to adapt to land. Two separate groups formed from the pioneer species, the phylums Bryophyta and Tracheophyta. Demands of life on land. Plants had to adapt in many ways to live on land. They needed to obtain a constant supply of water on land, needed sunlight, had to exchange water and carbon dioxide with the environment without losing a lot of water, and they needed to reproduce without needing a large amount of water. The phylum Bryophyte includes mosses, liverworts, and hornworts. Their life cycles involve an alternation of generations between a haploid gametophyte and a diploid sporophyte. Bryophytes also need water to reproduce. They can only live in wet areas and are most abundant in tropical areas. The appearances of all bryophytes differ, but all of them are less than a few centimeters tall. Mosses. The mosses you see are actually clamps of haploid gametophytes growing close together. They have thin branches called rhizoids that penetrate the ground and act like roots.
Liverworts. Liverworts are less common than mosses, but also live in wet places. They look like flat green leaves growing along the ground. When mature, they produce structures that look like umbrellas that produce eggs and sperm. Hornworts. The gametophytes of hornworts look similar to the gametophytes of liverworts. The sporophytes differ, however. Hornworts sporophytes look like horns, while liverworts sporophytes look like an umbrella. Physical characteristics of bryophytes. Bryophytes don't usually grow well in dry places for several reasons. For one, they lack the water-conducting tubes. They use osmosis and surface tensions to move water. They also lack a protective surface to stop water from evaporating. Bryophytes do not have true roots that they can use to absorb and transport water. They are rhizoids instead. However, rhizoids don't play a major role in the absorption and transport of water in bryophytes. Lastly, their sperm cells must swim through flagella to fertilize eggs. For this reason, their area must be wet for at least part of the year.
Alternation of generations in mosses. Miniums have reproductive structures similar to those of algae. The antheridium produces the flagellated sperm cells and the archegonium produces the eggs. The reproductive structures of mosses protect the gamete from drying out, unlike algae that do not. Mosses can have male and female reproductive organs on one gametophyte or separate gametophytes. Sperm swims to the archegonium through water. Syngamy occurs and a diploid zygote is produced. Syngamy is the fusing of gametes. A diploid sporophyte is produced once the zygote begins to grow. The gametophyte supplies water and nutrients to the sporophyte, which is why the moss gametophyte and sporophyte cannot live separately. The mature sporophyte has a foot stuck in the gametophyte, a long stalk, and a capsule that looks like a salt shaker. The capsule contains haploid spores that are produced by meiosis. Once the capsule ripens, special pores open and spores are shaken out and carried out by wind and water. Once the spores land in a moist place, it grows into a mass of tangled green filaments called a protonema. There is a strong resemblance from moss protonema and filamentous green algae. This is evidence of evolutionary change from algae. The protonema eventually form rhizoids that grow into the ground and shoots that grow into the air. The shoots develop into familiar moss gametophytes and the cycle continues.
Bryophytes fit into the world. Mosses are used for some farmers for decorative purposes. Farmers also use peat moss to improve their soil. Peat moss increases the soil acidity and increases its ability to retain water.